Welcome back. In this section, we'll talk about ELB service and we'll talk about its architecture. We'll talk about what ELB is. We'll talk about the ELB's features. We'll talk about how to architect our solutions or applications using Elastic Load Balancer. And then we'll also understand how ELB routes traffic between multiple instances or even multiple availability zones. We'll figure out how load balancer maintains health checks, how it conducts the health checks against the instances that we start in these multiple AZs. Then we'll talk about stateless and stateful sessions and how we can enable that feature within ELB. We'll talk about SSL termination, how we can use ELB to terminate our SSL connections from our user browser. And finally, we'll talk about autoscale integration, how we can use ELB and autoscale together to create a state-of-the-art application that scales. And finally, we'll talk about autoscale integration. We'll talk how autoscale and ELB work together when we are designing our applications in AWS. ELB features. ELB is designed for high availability. We want to set up multiple EC2 instances spread across either in the same or different availability zones, and then we want to distribute traffic to all those instances. So like we had described here, the instances can be in the same AZ or in different availability zone. Obviously, when we set up instances in the different availability zone, that is a preferred option. That's a best practice recommendation from Amazon. Then we'll talk about instance health check. So instance health check essentially means we want the ELB to detect the health of our instances. We want to make sure that ELB sends traffic only to healthy instances. If for some reason our instance becomes unhealthy or unresponsive, we don't want ELB to send traffic to it because we don't want our users to get a bad experience when they visit our websites. And when we fix our unhealthy instance, whether it comes on its own or we resolve that issue, we want ELB then to start sending traffic to that instance. We'll talk about security, how on the ELB we can terminate our SSL connections, and so that the users can communicate to our instances on the backend using the HTTPS protocol. And the other security features that ELB provides is called non-internet facing ELBs. So if you have a VPC configuration where you have your instances or application servers are on the private subnet, and you can keep that, you can load balance even across those private instances without exposing this Elastic Load Balancer to the public internet. So in a non-internet facing ELB, the Elastic Load Balancer or ELB does not receive a public IP address. So nobody can access it. Only your application servers or your web browsers know about this internal ELB. In ELB, there is support for stateless sessions and sticky sessions. By default, ELB sends traffic to all the instances, regardless of which user came through. So if you want to have something called a sticky sessions, where you want a specific user to be sent to the same instance, same backend instance every single time for the duration of that session, we want to enable these sticky sessions. By default, sticky sessions is not enabled. So the default choice is to use what's called a stateless session. So that means any instance, any user can go to any instance on the backend. For operations support, we have access to the log files that ELB generates, so we can know what kind of traffic we are getting, from which IP addresses we are getting, and what kind of requests we are getting. So those log files can be preserved in an S3 bucket. In addition to that, there is a lot of metrics, the CloudWatch metrics that ELB provides. Some of the metrics that we'll look into is our request count, request latency metrics, some of the backend errors. So if you're getting backend errors, all those metrics can be tracked using CloudWatch. Some of the protocols that ELB supports is HTTP, HTTPS, SSL, and some TCP ports that we'll see the details on the specific TCP ports they support. But most of the time we'll be using HTTP or HTTPS listeners. Some of the additional security measures ELB provides is you can configure your instances so that they accept traffic only from the elastic load balancer. So in other words, the users cannot directly access the instances. So we can configure so that all traffic goes through ELB. So this is the best practice measure that we need to set up when we design our applications. In addition to that, we can configure the security groups even for the ELB, just like we did in the previous labs for EC2 instances. So how do we design our application using ELB? So in this case, I have two regions, one in US East, and I am also using the Singapore region. I have a load balancer in each region that is routing traffic to two instances, one in AZ1A and the second one in AZ1B. So the traffic gets routed to both the instances. So let's say there's an instance failure, something happens to my AZ1B instances in both the regions, my application will still continue to function. All the traffic now is handled by the AZ1A instances. Obviously there's only one instance in each AZ, but if you can see this multiple arrows in the center of the screen, so that is my auto scaling group. So I'm auto scaling my instances so that if there is a failure in one of the instances, auto scaling will start a brand new instance for me in the two AZs. So this is the best practice of setting up your application in multiple regions, multiple AZs within the same region, and then use an auto scaling in case to detect failures or to scale appropriately to meet user demand. So let's talk about ELB health checks. So what I want to do is every few seconds I want the ELB to check for a presence of this file. So in this case I've chosen status.html, but it can be any file that you choose. So what I wanted to do is I created this file called status.html on every single web server, every single instance that's part of my application. And this is typically a small file. All it needs to say is OK or alive, ping, something like that. So every few seconds, I want ELB to check for the presence of this file. And as long as it receives a valid HTTP code of 200, that means this instance is up and running, and the ELB can send traffic to this instance. So essentially, ELB is looking for a valid status code of 200. Some of the parameters I can configure this health check is response time. How long should I wait for this page to return a valid status code? So this can be typically, let's say 30 seconds. So it waits for 30 seconds for it to return a valid status code. The health check interval, on the other hand, says how frequently I should check for this page. Okay. So this has to be let's say 1 minute. This has to be a little larger than the response timeout. So if you configure this to be 1 minute, the ELB is checking the validity of this page. It's looking for this valid HTTP status code every minute. Okay. And it waits for 30 seconds, in this case, if I configured it to be 30 seconds, to return a response code. The next parameter we need to configure is unhealthy threshold. So how many times should this page fail before I mark this instance unhealthy? Okay. So this is the number of times the page is allowed to fail. So let's say you set this parameter to 2. That means you're telling the ELB that as long as the page does not receive, as long as you don't receive a valid status code after 2 attempts, mark this instance unhealthy. The healthy threshold is the flip side. So let's say there is an issue with the instance and you go and fix that issue, and then the instance starts responding again. So healthy threshold essentially is telling ELB that this instance has to send this number of valid HTTP status code before I'll start sending traffic to this instance. So unhealthy is I'm not receiving valid status code from this instance even after this number of attempts, so I'm going to mark it unhealthy. So on the other hand, if the instance is up and running, it's sending valid status code, but I need to make sure the instance is really up. I need to receive at least X number of healthy requests. Only then I'll start sending this traffic to this instance. And all the parameters that you see are configurable. You can configure it in seconds, a number, anything that you want. All those parameters that suits your applications, you can change it. So this is the screen that you will see when you want to configure that option. So in this case, I'm talking for the instances using HTTP protocol. My backend instances are running on port 80. So this is a web server that I'm monitoring. And I'm looking for this file index.html. Okay. And I want to receive a response time within 10 seconds. So every 1 minute, I'm asking for this file index.html, and I want to receive a valid status code within 10 seconds. Okay. If I don't get a valid status code even after 5 attempts, I'm going to mark this instance unhealthy. So I'm going to make 5 attempts, and if it doesn't respond after 5 attempts, I'm going to mark that instance unhealthy. On the other hand, if the instance gets fixed, the issue gets resolved, I want to receive at least 8 valid status codes before I put this instance in service. Okay. So essentially, this is the health check screen when you're setting up Elastic Load Balancer. You're looking for this page, and every minute you're making that request, and you want to receive that response time within 10 seconds in this case, and you have to receive if you don't receive consecutively, if you don't receive valid status code, you're going to mark that instance unhealthy. And once the issue is resolved, you want to make sure that the instance is really up and running. It can accept the traffic, but I want to make sure I receive 8 valid responses from this instance before I put this instance back in service. So the next feature we want to talk about is SSL termination. It's also called SSL offloading. So essentially, this means when users make a HTTPS request to our website, the SSL connection or SSL termination ends at the ELB rather than individual instances. So it makes our life of our instances much easier because they don't have to decrypt the SSL traffic. They are not spending time decrypting the SSL traffic, encrypting again, and sending it back to the client. So my instances can respond much faster because that work is offloaded to the ELB. It also makes the operations easier. So because I'm installing the SSL certificate on the Elastic Load Balancer rather than the multiple EC2 instances, it's much easier maintenance. I just need to change the certificate in one place, and I don't need to, if I have, let's say, 50 instances, I don't need to log into every single one of them to install this SSL certificate. So this feature is called SSL termination, and this is how it looks from the end to end. So these are my clients, and they're making the green lines indicate HTTPS communication. They're making encrypted session call to my Elastic Load Balancer. The SSL gets terminated there. From the load balancer to the backend instances, it's plain unencrypted traffic, the HTTP traffic. So as far as the instances are concerned, the load balancer is making plain HTTPS request, but when it goes out, it sends out HTTPS connection back to the clients. So this feature is a very important feature, and it's either called SSL termination or SSL offloading. So the next feature we want to talk about is called sticky sessions. So ELB normally routes traffic independently, and this feature is called stateless sessions. So if you want to enable the sticky sessions or session affinity, when you do that, the user is bound to a particular instance. So as long as that session is valid, that user continues accessing that single instance. There are some applications that cannot do stateless sessions. They need to have sticky sessions enabled. Okay. So that's the reason ELB can also support sticky sessions. You can enable sticky sessions at the ELB layer. So the question then becomes, how long is the session valid for? And there are two ways you can configure it. You can set up a parameter at the ELB level. You can say, let's say this duration of my session is 1 hour. So that session is valid for 1 hour. So as long as that 1 hour is not expired, that user is bound to that particular instance. The better option is to let the application set the cookie duration, because the application is aware of what's happening in the at the backend code. It's in a better position to determine how long that cookie duration or the session duration should be. Again, this feature is called a sticky session. So this is how it looks from the end-to-end session. So I have a user coming from browser number 1. He's making 3 requests, R1, R2, and R3. Because the sticky sessions are enabled right now, the ELB sends all these 3 requests to one specific EC2 instance. If a second user comes in through browser number 2, he's making request number 4, 5, and 6, and he ends up in a particular instance, in this case EC2 instance number 2. So this is how the sticky session works. So if you don't enable, the request 1 could go to EC2 instance number 1, EC2 instance number 1. The request number 2 may end up in EC2 instance number 3. That if you don't have the sticky session enabled. Finally, we want to talk about integration with autoscaling. Autoscaling is a service from Amazon. It launches instances based on certain conditions that are happening in your infrastructure. These conditions can be high CPU, it can be the network traffic, or any other parameters that you want to track. So the increase or decrease of this server capacity are performed when those conditions that you specify are met. And once the instances are increased, the autoscaling can then register those new instances with the load balancers. And if there is a decrease in the scale down activity, when your high CPU goes, let's say below 10% or 20%, and you don't need that excess capacity, autoscaling will terminate those excess instances. And at that time, it can also deregister those instances from the ELB, so that ELB does not try to send traffic to the instances that are gone away. So this is seamless integration with ELB. You can use both of them together. So this is how autoscaling with ELB looks. We have our elastic load balancer here, and these two instances are permanent instances or static instances, let's say 1 and 2, and these are new instances that are spun off by the autoscaling service. And even though this is a new instance that was not there when you started this service, it gets registered with the load balancer ELB, and then once the application is up and running, ELB will start sending traffic to this instance. So we'll talk about ELB in the next section. But for now, we just want to mention that ELB and autoscaling works very well together. So in this section, we talked about ELB. We described ELB's features. We talked about ELB architecture, how to use it to design our architecture for application. We found out how to route traffic to multiple instances within our application. We learned about the health checks. We learned about stateless and stateful and stateless sessions. We learned about SSL termination and how ELB and autoscaling work together.